So today I'm gonna just provide some of the findings we went through in the past several years, including actually the recent 2 years with Terrence's team on the variable rate spraying, but also with the engineering team for the 3D tree characterization that can enable more robotic, pruning or management for orchard systems in the future. So just the topic along with what Terrence just shared. It was actually even a surprise for me as an ag engineer when we put a lot of expectations in the first year, try to use the variable rate spraying, and with the belief that GPS information or georeferencing should be already done because this has been the practice now for many of the commodity crops like corn and soybean in the US. But we ended up with a failure story in 2025 when we firstly conducted this experiment and really kind of motivate us to revisit the GPS issue for orchard systems, specifically for the apple orchards across the nation. So that kind of give us another round of the opportunity to really provide more objective evaluation, right, of the commercially available RTK GPS systems that can provide either sub-inch or centimeter level positioning information to enable the precision for any of the management for our ultra system. And one of the very quick survey we did with the New York growers was that most of us was still kind of behind the game in terms of fully integrating GPS, especially RTK GPS, into their regular management practices. So basically, the challenge is when you think about RTK GPS system, we have two required units. One is the rover, which usually being mounted either on a tractor or being handheld that you can measure exactly where you are. And then you can accordingly provide actions to the trees or conduct any of the operations by yourself. And the other unit is actually called the base station, which is a permanently fixed location with the GPS antenna to get the correction signals and spread out to your rover unit so that your rover unit can get the centimeter or sub-inch level accuracy. And in traditionally, there are very well-known agricultural brands for RTK GPS, include Trimble, which is a kind of a sort of a division of John Deere or the John Deere ecosystem, and also Raven as a separate vendor. And of course, for many of the conventional field robotics work, we use a vendor called Novatel, which is actually the OEM manufacturer for both Trimble and Raven systems. And they provide very reliable and reputable GPS systems. But of course, if you look at the price per unit, which means you need to have a rover and a base, right, for a very basic function, we are talking about $15,000 to $20,000 as a upfront investment. And with that increased interest of precision management for specialty crops in general, many of the emerging GPS companies, provide more affordable options such as the AMLEAD Reach or U-Blocks or the Top Gene SS, which manufacture outside the US, provide like a couple of $1,000 to a couple of $100 options. And we are interested in whether or not our growers can actually also invest in those options and build a reliable RTK GPS systems to enable the precision management for their orchards in the future. And I would like to share a little bit more technical detail. And the reason in 2025 we were failed is mainly because different technologies like the camera systems or later on the sprayers use different RTK GPS systems. And if they share the same base station, which provide the same correction factor, then the rover measurements will match with each other. However, in many of the cases, they use totally separate base station correction subscription or their own base station, and that sometimes create the technical glitches that can cause, sometimes up to a meter shift, and which in our management context that can ruin the whole plan. So we provide, different configurations of different, RTK GPS pairs with different units as rover or base station to give a different, scenario. And also we use different communication, tools, either that's through internet, through the cellular cell phone network or the local radio, and try to test in different scenarios which one can give you a reliable RTK GPS system for your orchards. And these are some of the examples from AMLEAD, because as I mentioned, Novatel, Trimble, Raven, you can easily find your local distributor and they have the full, customer service to set up everything. But the only, factor really worrying you is the upfront cost. As I mentioned, $15,000 to, $20,000 without any of the additional customer service cost. And this AMLEAD system usually costs a couple of $1,000s to build the whole system. And sometimes you could use either for mounting on the tractor for precision guidance, or later on the variable rate spraying guided by GPS, or even the handheld one that can survey your individual trees in the orchard to provide the base map for the variable rate spraying. And here is actually the example of the individual trees actually measured by Brian Lawrence, former postdoc with Terrence. And that's the base map used to generate the variable rate task map that was used by different spraying systems Terrence just shared. And when we kind of tested out different configurations, and we found in general, doesn't matter which of the brand we were testing, they all provide relatively very high performance in terms of how to geo-reference your individual tree, which basically to tell where your trees are. And then when your sprayers gets into the system, it will know, okay, this is for tree 1, and the blossom map tells me I need to lower down the rate, and that's where the GPS will tell the sprayer I need to turn off or lower down the pressure for that nozzle to kind of reach the proper goal. And in addition to a kind of stationary or static scenario for georeferencing, we also put all these GPS units on the mobile robot platforms to test whether or not when these systems are moving in the orchard or trellis system, their performance may drop because sometimes those high or tall trees may prevent or block the signals between the base station and the rover units. And sometimes that can cause the degradation of the signal strength and later on the accuracy. So with our tests, repetitive tests, we found again, all of these configurations under successful communication, we achieve pretty high positional accuracy as well as the heading accuracy that can really be used as a reliable option for the precision management in orchard systems without any hesitation. And later on, we kind of summarize it as 3 different scenarios. So if you still want the most reliable, most hands-off option, Trimble or Raven or Novatel, which usually 10,000 per unit, still being the option there. And they are they have a very long history track record that everyone trusts them in the field conditions. And if you are thinking whether or not I should invest that and you want just to give it a try, some of the very economic solution like the U-Blocks, only $200, could be your starting point. And with our kind of extensive experiment, we found the best balance option is actually the Reach RS3, which is about $2,500 per unit. So you may spend about $5,000 to build your own RTK systems that can unlock the potential for future variable rate spraying by yourself. And also in terms of the communication, we prefer to use the network-based transfer that can be either through your local Wi-Fi or a cellular-based internet transfer, which usually won't be blocked by the tall trees that can jeopardize the accuracy of your GPS system. And also another very important factor you may consider is the format of this GPS output, because we are talking about connect all these informations across different technologies. And we want to try to make sure we use the open, source format that they can cross-talk with each other without any other, proprietary, subscription or information that may block you to fully realize the variable rate precision spraying. So now a little bit kind of shifted the gear just about the project I'm involved heavily about the 3D characterization for apple trees and some of the data management and visualization. So basically, you all put a lot of expectation for agriculture robotics in general, especially with the increased labor shortage. But one of the key bottlenecks for all the agriculture engineers to develop these robotic systems are actually seasonality. As compared with many of the roboticists, developing those humanoid robots, we actually only have a couple of weeks that we can fully test and develop our ideas in a year, as compared to 12 months for any of the indoor robots. And the other thing is the data scarcity. So you may hear a lot of AI breakthroughs almost every single day about how generative AI can be used for different sectors. But when you look at for agriculture, we still lack of the data needed to boost all these AI tools for agriculture production management. And here is actually the diagram. Most of the industrial sectors is actually close to the irreducible error region, whereas agriculture is actually at the very beginning, almost close to the small data region where we just started and we need more efforts on that. So to fill in that gap, my group proposed this closed loop framework. Basically, we want to use a small set of the realistic data so that we can learn how this information being kind of presented in the real world and summarize them as knowledge and put into a model that can train a generative AI generator to create a synthetic data that can help us to gather large data sets for training analytical AI models that can help us to characterize or analyze the tree architecture and provide that information for some downstream tasks like pruning, or sometimes we just talk about calculating different tree cross-section area. And in the past year, that's the whole framework we built, and now we have the full pipeline ready to generate tons of the data to fill the data gap faced by the agricultural engineering society. And particularly, I want to highlight, we actually built an autonomous robots now can take the RGBD sets for depth, which is the distance between your robot or your camera to the ambient, so that we can gather all the imagery data in a much faster way. And here we estimate about 30 seconds, we can cover 30-meter block. And with the closed loop, concept or framework, here is our pipeline. By utilizing this imagery data set, along with the knowledge we learned from the realistic apple trees, we can reconstruct the 3D models of all these apple trees. And later on, we can also train the AI model to segment these 3D point clouds into trunk, primary branches, and branches at higher order, so that we can characterize, for example, the trunk diameter, the tree height, and also the branch diameter and the branch inclination angle. So as Terence shared earlier, one of the efforts we are still working in progress is whether or not we can combine these different geometric traits of our apple trees to accommodate, the maturation of the trees that will result in less effective of use the tree cross-section area to correlate it with the ideal crop load in the future. And meanwhile, this framework allows us to generate, the pruning strategies. Here is how the robots collect all the apple tree images in the field and reconstruct their 3D structure. And later on, we use the AI models to also identify, based on the horticultural pruning practices, which branches should be preserved and which branches should be shortened and which branches should be totally removed, that we can achieve a better or ideal tree architecture going along with the season. And I hope Long will share more about his work on the actual pruning mechanisms, so that our hope is we can really, roboticize the pruning effort. As Terrence mentioned, if we get the right start, everything gonna be much easier along the season. But we also realize, how challenging for, robotic pruning, and that's, where this project really laid the foundation for the future work. So with that said, I'm not sure if I still have time to take questions, but thanks everyone for supporting the past, almost 5 years for our work in various aspects. Yeah, back to you, Terrence and Craig.
Thank you, Yu Jiang.
Thanks.
We're going to answer questions related to either variable rate spraying that I talked about or Yu Jiang's work on tree characterization or GPS right now.
Here's one. With variable rate application, how are you calculating rate of product active ingredient being applied per tree? And is water volume an issue, assuming most PGRs require slow drying conditions?
So the way we calculate rate is we have within Cornell's database, which I wrote, the standard rate for each variety in the heavy bloom. So for example, the Golden Delicious trial we did on our good bloom, we would have a certain rate of NAA plus carbaryl that we would apply. And so the variable rate would then be either that 100% rate of our standard rate or some 50% rate or zero. In terms of the water volume, yes, it does have an impact, but we generally have settled in New York of spraying less water volume than a full dilute spray, because we've shown repeatedly that you still get the same thinning response whether you spray full dilute or half the water volume or a quarter of the water volume. So those ranges from full dilute to a quarter of the water volume essentially give us the same thinning, as long as the total chemical per acre is the same across those water volumes. So that's a quick answer to both of those questions.
Can you utilize pulsating solenoid valves located at the nozzle itself to gain the adjustment speed necessary to target individual trees? The Smart Apply system is able to adjust down to the centimeter by using pulsating solenoids.
Yeah, that's another possibility that we could utilize. It's a good question whether we need to do that as we go down the road, because it's the total chemical applied to that tree, milligrams per tree, that determines the thinning response. And so you've got to be able to get a certain amount on the tree, and the quicker you can turn that valve on or off, the better.
Has a team looked into developing a task map by tree count in a given row as opposed to GPS points? The ground-driven estimators have ability to take tree counts, and a Smart Apply system is also actively counting intra-row. This may lead to increased accuracy and possibly easier communication between the task data and the operator.
That's a possibility, although it's not so easy to distinguish where one tree ends and one starts depending on the system. In V systems, it's not that easy. And so I'm skeptical that Smart Apply can take an accurate tree count. Do you want to comment on whether you can do tree counts versus a GPS coordinate?
Yeah, so I want to just make a comment on that. So definitely from the current technology, we would have the possibility of doing so. But then again, the risk is how many times the growers would take the risk of missing one apple tree count by the system and then jeopardize the rest of the row. So I think that's the key balance, right? Not all the systems are working 100% accurate, and sometimes even human, miss the count. And in such scenarios, I think then we need to consider what's the balance there.